This is another simple question here. The question says that the uniform rod below is 100 centimeter long. If the rod is in equilibrium, what is its weight? We are told that this is a uniform rod that is 100 centimeter in length. The rod is placed on a pivot, but we are told that the rod just balances on this pivot. That is, it is at equilibrium on this pivot when a weight of 20 Newton is hung from the 20 centimeter mark. Our target in this question is to find the weight of this rod. The rod is uniform, which means that the weight of the rod must be acting at its center of gravity. So what will be the center of gravity of the uniform rod? For a uniform object, the center of gravity is always at the center of the object. The center of this 100 centimeter rod, 100 centimeter long rod is at 50 centimeter mark, which means we can apply the weight W, we don't know it, at the 50 centimeter mark of this object. Now the object balanced on the pivot, which means we can take moments about this pivot. Taking moment about this pivot means this weight will create a clockwise moment because it will cause the rod to rotate in a clockwise direction, while this weight will cause an anti-clockwise moment because it will cause the rod to rotate in an anti-clockwise direction about this pivot. We know that for this object to be balanced, the clockwise moment must equal the anti-clockwise moment. So what is the clockwise moment? It is the product of the weight, W, times the distance away from the pivot, which is 50 minus 40 to give us 10. So the clockwise moment becomes 10W. W times the distance 10 equals 20, the weight, times the distance between this and the pivot, which is also 20. So we have 20 times 20. To obtain W, we divide both sides by 10. So that W will be equal to 20 times 20 divided by 10. And that will give us the weight of the rod to be 40 Newton. So you can see that it is very simple and straightforward. I believe you enjoyed this and you understood it as well. If you did, then here is a simple one for you. Try this. If the weight of the rod is 50 Newton, what will be the new position of the 20 Newton weight to keep the rod at equilibrium? Assuming that this weight is no longer 40 but 50, definitely this 20 Newton will no longer be here. It has to move away. The question is, where will be the new position of the 20 Newton weight to keep this object at equilibrium, assuming the rod is now 50 Newton weight? Put your answer in the comment section and I'll be there waiting for you. Thank you for watching this video and hope to see you in our next video.